Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2023 NHT Physics examination. We will focus on questions related to light as a wave. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Only transverse waves can be polarized. The amplitude is the maximum deflection from the baseline. B is the wavelength. The speed of light is in inverse proportion to the refractive index. So, the speed of light decreases when light is traveling through the block, of which the refractive index is larger than air. However, the peak number remains constant, so the frequency of light in glass is the same as it in air. To keep frequency constant, the wavelength of light should be decreased. So, B is correct. 2.5 wavelengths in the 5.0 meter string results in a wavelength of 2.0 meters. One wavelength is 5 divided by 2.5, and the value is 2. We know the value of frequency and speed. The speed is the product of frequency and wavelength. So, the wavelength is speed divided by frequency. Volume depends on the path difference between the location and the speakers. If the path difference is a whole multiple of the wavelength, then constructive interference will occur and the volume will be loud. If the path difference is a whole multiple of half wavelength, then destructive interference will occur and the volume will be quiet. Both speak are the same phase and wavelength, and the length between the two speaks is 16 times 1/4 of the wavelength. So, the standing wave is formed between the fixed and opened ends. In this standing wave, the distance between nodes, quiet points, is half wavelength. Generally, the distance between antinodes is also half wavelength. There is a difference in the sound due to diffraction through the door opening. Longer wavelengths that approach the width of the door diffract more than shorter wavelengths, so the shorter wavelengths will sound softer relative to the longer wavelengths. We know the refractive index of the core and refractive angle, then calculate the incident angle with Shell's law. This is a total reflection. The refractive angle is 90 degrees, and the incident angle is 59. We calculate the refractive index of cladding step by step. Band 3 is a point of destructive interference. The path difference is an odd integer number of half wavelength. Band 3 is 3 times of half wavelength. It is an experiment of double-slit inference. We know the space of two slits, the distance between the slit and screen, and the wavelength, then calculate the band spacing step by step. When the whole apparatus is immersed in an insulating liquid, the wavelength will decrease because the refractive index increases. We first calculate the wavelength of light, then the spacing of bands. 3 multiple-choice questions were awarded for 3 marks. 4 short-answer questions were awarded for 20 marks in light as a wave. The overall score for this section is 23 marks. With a total possible score of 130 points, the percentage for this section is 17.7% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.